Hi everyone and welcome back to Maths and Physics from Mr. Simons. Today's grade 12 inverse functions lesson. We are refreshing what you should know of a parabola given the equation y equal ax squared plus bx plus c. And the next lesson we're going to look when we've completed the square, the second equation. So this is just a summary to make sure we understand all the things we need to know for a parabola. So number one, my general equation, y equal ax squared plus bx plus c. The a in front of x squared will always decide the shape of my graph. Right? So if a is a positive value, it's greater than 0, I have a smiley face, meaning the graph is concave up. If a is less than 0, we have a sad face, or meaning the graph is concave down. All right? So A positive, we're smiling. So when you're positive, you always have a smile on your face. And when you're negative, A thing, you tend to appear sad. Right? So let's hope we get you all to being more positive instead of negative, right? So 3, x-intercept, as I said in the previous lesson, will always be y equal to 0. Y-intercept will always be x equal to 0. Right? So 0 equal ax squared plus bx plus c. Y-intercept, y equal a. Wherever we see x, we're going to place 0. Alright, so for x-intercept, when I make y 0, for the parabola now to get the x-intercepts, we're going to require factorization. So x-intercept will always test your factorization skills. And y-intercept, when I place 0 in the place of x, the only thing that's left is c, because c has no x attached to it. So in short, whatever I write here, if it's 5, you can go straight to y-intercept, y equal to 5. All right? Now, graph and its points, because I'm doing this because I've seen some learners be like, why you say y-intercept, x-intercept? Right, they have the x-axis, they have the y-axis, sorry, and the x-axis. Right, so my parabola in green, wherever it cuts the y-axis, where it makes contact with it, that is referred to as a y-intercept. Right? The parabola, not always, but most of the time, the questions we give you, when it cuts the x-axis, it will cut it at 2 places, can also cut only at 1 place. Those 2 places are referred to as my x-intercept. Alright? There where it turns, that is called simple terms, my turning point. Right? And then if we draw a line through the turning point, a vertical line, what we are technically saying, we have an axis of symmetry, meaning this half of the graph must look exactly like that side of the graph. We must be able to fold it over each other, right? The axis of symmetry is simply the x value of the turning point. Right? So I hope this makes sense to you. Right, and we need to know all these things because we're going to use all these things to catch you out finding equations, etc. Right? So for axis of symmetry, turning point, domain, and range, we have the equation y equal ax squared plus bx plus c. For the axis of symmetry, x equal minus b divided by 2 times a. All right, that's the equation. All right, then for the turning point, we have what we call the p and the q value. My axis of symmetry is my p value. So p equal minus b over 2a. Right, and this here will then be substituted into the original equation. So wherever I see x, I'm going to put p. So there p squared times p, and whatever answer I get here, that's my q value of my turning point. Right? For most of our functions, my domain will always be x element of real numbers, meaning when I draw the function, it will make contact with all the x values. The only time it's not x element of real numbers is when I'm dealing with asymptotes. All right. Now, for the turning point, see I have a smiley face and I have a sad face. That there is the lowest y value. So from here, the graph can only go up. This is my highest y value. So from there, the graph can only come down. So when the graph goes up, it's greater or equal to. the graph goes down, it is less or equal to. I hope that makes sense to you. So there, if I say if a is greater than 0, smiley face, my range would be y greater or equal to whatever the y values of the turning point here, which in this case is 0. So y greater or equal to 0, or my range, I can say 0 to positive infinity. So 0 increasing to positive infinity. Yeah, y less or equal to 0 there because it's turning by 0, or my range always from smallest to biggest, negative infinity to 0 there in the top. Right, and because 0 is included, I have a square bracket, there's square bracket. For infinity, it must always be open bracket because we don't know where positive infinity ends and negative infinity ends. Right, I hope I've done justice. I hope you follow me. Please like and subscribe. God bless. Bye.